Good morning, class. Sorry I can't be with you today to kick off Project 3, so I'm making this video. Here is an example of what we are working towards, albeit maybe with a little more shading. But yeah, I just want you to look at this page. So Project 3, there is a brief in the syllabus, but we're drawing real-life objects here. So in this instance, this is a web camera. And just, I want you guys to notice the layout. So you have a object on the top left, nice and big. In this instance, it's a very simple drop shadow, but we'll be getting into calculating and plotting cast shadows later in this video. But also just look at the bottom right. This is also a new thing, at least in our class. The terminology is orthographic views, which I have written out here. And basically, this is just showing this three-dimensional object on the left in 2 dimensions. So you'll notice that there's the front view, which is sort of the main view. Then notice that the views corresponding to this main front view actually face it. So on the side here, the front of the camera is facing the front view. And on the top view here, the front of the camera is on the bottom. So this orientation is important. It's also important that they align top to top and bottom to bottom and side edges to side edges. I will give a demo of this as I go over the basic geometric shapes with shadow plotting and set this up. This is, so before we get into these assignments, I want to talk about some basics on shadow plotting. And that's the main goal today. I already explained the basics on 1, 2, 3 shading as well as matte and gloss. So this is building onto it, and shadows can help add a little more information to the object that you're drawing. It can help communicate its form, where the ground plane is, where it exists in space. So, intro to shadow. Imagine that this is a ground plane in 2 dimensions. So maybe we're looking at a stage. Perhaps there is a street lamp on the stage represented by this very simple pin, and maybe there is an actor standing here. This light has 2 relationships to this figure. One is the direction where the light is. In this instance, because it's 2 dimensions, it's to the actor's left. The next relationship is the angle at which the light is being cast, in which case corresponding to the height of the light. So when this angle comes down and touches the head of the actor, where this angle and direction meets down here, this represents the length of the cast shadow of the actor. So if we were to draw a shadow on the ground, it would be about that length. Again, just like everything else we've learned in this class, this is a very basic explanation of shadow and is used as a shorthand to calculate something that's relatively accurate and relatively close. So if we play with this, I talked about the direction and angle in a 2D plane. So let's diverge a little bit into getting into 3 dimensions here. If we move this street lamp a little bit in front of this actor, and now imagine that he's standing, you know, on a basketball court or something, or this is a more 3-dimensional view of the stage. First, we're going to plot the direction. So again, this is the relationship of where the light is on the ground plane, mainly, to this actor. So that's the direction. The next is the angle, which again is represented by the height of the light to the top of whatever we're plotting. Again, in this case, it's this figure. And so again, this is where they meet, and this is the length of the shadow. So we use this technique, of course, when we start to get into 3D shapes. This actor begins to be represented by the edge of an object. So if this is a cube, this might be, you know, of a cubic face, this might be one of the edges that we plot, that we will then go around and plot all the edges to find out where all these lengths are, and then it's a simple matter of connecting the dots. And again, I'll show that in a bit. Before we get there, though, you know, if we want to think about this as lines, I guess one thing I want to point out first is that you'll notice that this relationship here is plotting a triangle shape. And that's what we do as we walk around and plot shadow lines, is essentially just plotting these triangles. And again, the triangles are made up of this edge on the object, the direction line that represents where the light is located on the ground plane, and this angle line, which represents the height of the light. Before we get into full 3D, I think it'll be useful to use the same technique to talk about more two-dimensional shapes that are representing maybe like sheets of paper and what those cast shadows will look like. And again, this will be useful in a little bit. So again, here's our light source on our pole. Here's maybe a wall, a paper thin wall, or a sheet of paper. And now we start by plotting the direction line on the ground plane. So when it comes to 3D shapes, we simplify the technique. And we do that by doing horizontal lines that are, or not horizontal lines, but direction lines that are parallel to each other. It is possible to try and do a slightly more accurate technique where it's similar to the vanishing point, where, for example, if we were to start with the angle lines here, and we wanted them to pass, through these edges and corners, we could start all these lights and angles from the same points, but that can get really complicated. And again, a shadow plotting is just a shorthand to get us close to something that looks right. It is much simpler when it comes to shadow plotting to just take lines that are parallel to each other, which would look something like that instead of converging at this point. Just like everything else we do, it's up to you kind of to set up your where your light source is to begin with. So for example, if this angle is where I prefer the light to be, I can kind of move it, and kind of center it between these two lines. When it comes to actual plotting, just like we learned with perspective, you don't actually necessarily pick a light source point that's physical on the page or in space. You just kind of choose the direction and the angle, and then you just go parallel to it. And again, that'll be hopefully clear in a minute when I move to 3D. So to begin with now, again, I'm just showing you these parallel angle lines. Then we're going to have some direction lines. So again, this is on the ground plane where this light is in relationship to this paper. Once again, where the objects intersect is where the cast shadow is. So before I showed you casting a shadow on a single line represented by the actor. So again, you'll see the relationship of these triangles. So again, here's somewhat representing the actor. Here's this line. We don't see this because it's behind the piece of paper, but it comes to here. Now the new line that we're plotting is this top edge. And really it's a matter of connecting the dots between where these angle and direction lines intersect. And just drawing a line across there. And now this is our shadow for our piece of paper. You'll notice a certain relationship here. These vertical lines on the piece of paper, they are plotted in line with the direction line on the ground plane. So anytime you have a vertical line on your object that ends up being plotted as a shadow, it's always going to be represented in line, collinear with the direction line on this ground plane. Again, the angle line determines how far the shadow is cast. So this light's pretty close and above the object. If you take a really slack angle, like this way, I'll tend to refer to these as noon versus sunset. So when the sun is low on the horizon, it casts a nice long shadow, and that's kind of represented by this long angle line. If it's closer to noon, this might be more of an 11 o'clock, and a noon light would be directly above our object. It's going to cast shorter shadows. And we'll get into this in a bit, but the length of your shadow does matter, and mainly compositionally. I think it tends to look better when they're a little bit closer to noon lighting. Sunset lighting is more dramatic, but can make for really complicated compositions because your shadow gets really long. And again, we want to try to keep things all on the same piece of paper and not have it bleed off the edge. All right, one last two-dimensional example. This is going to be useful when it comes to plotting, and I'll show this in a bit, but when it comes to plotting a cylinder line down, this technique of this paper thin edge is going to be useful for casting this ellipse onto the ground to figure out what it does. And again, I'll show you guys that in a bit. One last paper sheet demo that I want to give. So let's take the same light source here. For those curious, I'm using a program called Sketchbook. It is free, actually, just of this year. So if anyone wants to download it and borrow a tablet from the print lab, you can try messing around with digital sketching. So moving on, we have this floating piece of paper in the sky with our light source, similar light source. Again, what's important in shadow plotting is the ground plane. This is establishing where the ground is. This can be confusing sometimes because it really is up to you where this ground plane is. But more often than not, the ground plane is represented by the base of your object. So if I draw a cube, the ground plane is often this face right here. So that's an important distinction to make. So in this instance, I just drew this rough ground just so that we have an idea of where it is. And of course, a plane technically exists infinitely in all directions. But it helps to sometimes define the edge. And I think that infinite aspect of it is what is maybe confusing. So we have this floating piece of paper here in the sky. So in this instance, the basics of it is if we're showing this angle from this light, and basically, again, I'm just taking these parallel lines as a shorthand to cast this onto the ground. What's actually needed for this paper is again, why the ground plane is important is we need to know where these corners have a corresponding relationship to the ground. And you'll notice like I'm starting to draw essentially a cube here because I need to find out roughly where the ground plane of this face is. Now, the reason why this is important is all of these corners where I've drawn angle lines through have to have a corresponding direction line beneath them in order to plot, where these intersections are. So for example, this first back edge, the center edge here, this is this corner where this angle line is hitting. The direction line is going to be corresponding directly beneath it. And this is where the direction line passes through, and then where this angle and this direction intersect, that's our first plotting point of our shadow. You'll notice I've started circling these intersection points and all of these lines on the page. That's because with all the lines added, it helps to know like which angle line, which direction line this angle line corresponds to. You'll notice it passes through both. And just like we did with the actor example, we're making triangles, and it's important that the triangles all correspond. If I were to accidentally circle this point here, this would be the wrong kind of triangle because it's not corresponding to that edge. So circling your intersections that matter is useful for when it comes to the point of connecting the dots. So again, in this instance, this shadow would look somewhat like that. Now, the reason for this demo is to point out, hopefully, a relationship that becomes obvious, which is whatever the top face of your object is, that's going to be represented in the shadow. Now, sometimes, again, if this is a cube, and you'll see this in a minute, part of these edges are obscured by the vertical edges within the cube. But it's safe to assume, especially when you start to approach complex objects, that whatever the top face is, if you start to think of it as a sheet of paper and you just kind of ignore the vertical edges, you can imagine that the shadow cast on the ground is going to be very similar to that. So, if I were in class, I would pose this as a question, but if the top face is an ellipse, a paper thin ellipse, I know you guys all get this already. There's going to be an ellipse shadow cast on the ground. And again, this is going to be useful when we get to cylinders. Hopefully that's clear. Again, I'm sorry I can't be with you guys, but feel free to email me with any questions, and I will take the time to answer those. Or of course text too, if you would like. All right. With that introduction said, the plan now is to go over these 4 basic geometric shapes. So, really it's 3. So the cube will be very instructional. We have 2 cylinders, the what I call the soup can and the steamroller wheel, and then finally the sphere. I would like you guys to follow along, and this is the assignment that will be due next time we're in class together. I'll include these 4 sheets with the email, so if you have a printer and you want to print them out, you can do that. Or if you just want to draw a cube in the top left corner of your page, you can do that. And again, this is important for composition because we're going to get into some orthographic views in a minute, and those will be down here. All right, so hopefully the direction and angle demos made sense, and now we're going to get into it with full 3D shapes. So when it comes to 3D, there is, and just like when we learned how to draw a cube, we started with the leading edge and kind of went back to perspective. There's a similar order of operations that makes sense when it comes to shadow plotting. And when it comes to shadow plotting, the edge that makes sense to start with is the edge farthest from the shadow. And more specifically, the corner farthest from the light, or sorry, the edge farthest from the light source, or the corner furthest from the light source, more specifically. And why that is when it comes to plotting the shadow, this is going to be the farthest point of our shadow. So this allows us compositionally to throw the shadow where we want it so that it doesn't go off the page. So for example, if I were to take an angle line here and plot the shadow way out to this corner, this angle line is going to correspond to a direction line. So this angle line is touching this corner. There's going to be a direction line which, as I mentioned previously, corresponds vertically beneath where the angle line is touching. So this direction line is going to go through this back corner here. For simplicity, for direction, I'm just going to choose a light source that is directly to the left of my object. Compositionally, it makes sense for your shadow to either be cast to the side or straight back. Casting a shadow forwards would tend to mean that your object is backlit, which is something we try to avoid. But for simplicity for these demos, I pick a light source that is exactly to the left of your object. And if that's something that you want to do for all of your shadow plotting, that's perfectly acceptable. So again, we have this angle line in green, which is representing the height of the light. And we have this direction line in red, which is representing where the light is located to the object within the ground plane. And again, where they intersect, which I like to circle, is one of the points of the shadow. And because we started with this far right corner of the cube, this is going to be the farthest point of the shadow on our plot. And again, we simplified this. Just, this is like the actor in the first example standing here with the street lamp casting this shadow. But we walk around and we do this 3 more times essentially. Now we could do it 4 times, but I'll explain why it's only 3. And again, hopefully it makes sense. So just like we chose this slack angle line here. I'm going to do the same now for this corner. It doesn't really matter whether you start with angle or direction. But find what works for you and just kind of stick with it. Hopefully it helps by sticking with one to remember its order of operations. So we got an angle line coming here. Again, it's parallel to the first one for simplicity. And then we have our direction line along the bottom here, also parallel to the first one for simplicity. And now, again, if I were in class, I'd pose this as a question. If this is our angle line up here, I've already shown you the answer, but the direction line always corresponds vertically beneath it, to the corner beneath it. And again, I like to circle this line where they intersect because it becomes a matter of connecting the dots. Without circling where this intersection is, and when all these lines end up on the page, there may start to be confusion, like, is that a dot that needs to be connected to? But by circling it, it allows my eye to ignore these other intersections that don't matter. Now, as we work our way around, I'll pose this next one as a question. So maybe here's our angle line. And again, the angle line is going to be parallel for simplicity of our objects. And then the direction line, if I were to pose this as a question, whether it's point A or B, hopefully you know by now that the direction line is corresponding vertically beneath where the angle line intersects. So in this case, it would be B, where the angle line, where the direction line goes. And now, just like I've been doing, I circle where the object intersects, where the two lines intersect, and that gives us a sort of a connect the dots situation. Now, we actually have enough information now to plot and complete this shadow for the cube, but for the sake of explanation, I will plot this left edge. Again, if I were in class, I would pose this as a question to anyone to say, why isn't this left edge important? And the answer is, when the light hits this edge, the light is passing kind of into the object, so to speak. You'll notice where this edge intersects is actually inside of the object. So the light actually isn't cast in there. We know it's an opaque, solid object. It's not transparent. So we know that this edge does not need to be plotted. It's really these far right edges. If the light source is to the left, it's all the far right edges that need to get plotted into the shadow. But if that's confusing, you can plot each edge and color them in and just use your object to obscure the shadow is another way to go about that. But it's just a little more work. So, all right, so we know that the light's coming from the left. It's hitting this leading edge here. And as we mentioned before, again, if this is our really skinny actor here, we have this shadow that's been cast on the ground. And we know that any vertical edge corresponds collinearly. Say this, it's the same line as the direction line from where the light is coming from. Now the shadow travels along the ground, representing this edge, up to the point where they intersect, and that's where it stops. Next, it's a matter of connect the dots. So if we follow this edge up where the light is casting past this edge, the next part of the light is going to cast along this edge. And we can see that it's connected by this green circle and this green circle. And that corresponds to this intersection point and this intersection point. So this is the next part of our shadow plot. You'll also notice that this line here is roughly pointing in the same direction as this line. Again, it's not perfect. There are more complicated shadow calculations that relate to the vanishing point. But again, I advise for the simplicity, and just know that these relationships can be helpful when it comes to plotting a shadow on a more complex object, that roughly these horizontal edges, they're not parallel, but they point roughly in the same direction. So as we travel along our object, we have this edge that we just plotted here. The next edge, again, could be posed as a question, whether it's this edge or this one here. But again, just like I explained, the light isn't really hitting this edge. It's obscured by the objects. And really the light is actually going to come back and hit this edge. You know, this far right edge is represented by this direction line. But you'll see when we're done, this direction line is within the shadow, so it doesn't matter. So as our light travels around this cube, it goes from this far right corner to this back left corner. This top horizontal edge is going to be cast on the ground, and that's going to be represented here. And now finally, as we walk the way around, we have this back edge, and it is helpful to draw the hidden edges on your objects when it comes to shadow plotting for this very reason, where we know where this angle line corresponds to this direction line. And again, because this is a vertical edge, we know that a vertical edge corresponds in the same line as the direction line. And we have our shadow here. So again, it's really a matter of connecting the dots once this is all set up. And for now, I like to represent my shadows with parallel hash marks. But you could also take a marker if you wanted to color this in. But that is our plotted shadow on our cube. Now it depends how closely you are following what I'm doing. If you cast a shadow similar to me, far off to this corner here, or this edge of the paper, that allowed us to see this corner intersection from this back line. It's very possible that if you cast a shorter shadow on this cube, that this intersection point here might actually happen on this back edge. So what that would look like is if maybe this is your angle line, and if I just plot all of this real quick and take these intersection points, it's possible that in blue here, this is maybe what your shadow looks like. And that's because part of your shadow is meeting back here. So again, that's the basics of plotting a shadow on this cube. Moving on to the cylinders. So you'll notice too that I used a cube to help construct this cylinder. It doesn't hurt to have that. And again, what this prism does in blue here, light blue to represent my underlay, it establishes our ground plane, which again can be helpful. Now you'll notice the confusing thing about the cylinders, there are no corners, okay? And before we were using the corners to help correspond our angle lines to our direction lines directly beneath them. So let's start the same way. When we start with our angle line, again, I like to start with the farthest edge. So on a cylinder, this furthest edge is going to be, if the light is to the left, it's going to be somewhere here on the right. Now it could be this point where this vertical wall hits here, but more accurately, when this angle line passes through this cylinder on this far edge, I like to have it hit tangentially. So again, passing, but touching but not crossing. So here's my angle line coming down and touching the cylinder roughly here. Now the question is, where does the direction line go to correspond? Well, hopefully by now we know that the direction line always corresponds to a point vertically beneath where the angle line touches. So if I plot a point directly beneath here, and again, this is why it's helpful to draw the hidden edges that we don't see, I can see that where this vertical line crosses this bottom ellipse here, this is roughly where we can put our direction line in that corresponds to where our angle line hits. So this is the first part of our shadow. Now again, we're taking a light that is directionally to the left of this cylinder. So in this instance, I'm actually going to start with direction lines. And I'm going to take another direction line that's tangent to this bottom ellipse. And just like we did back here, we can trace this meeting point vertically up on our shape And where this intersects, we can take an angle line that represents the height of our light that's parallel to this other angle line and circle where this meets. And I should have done this before with this one, but circle where that meets. And again, we're just plotting triangles. It's just triangles on the page. Now, same thing with the light to the left here and this ellipse on the ground. Opposite here, we're going to have another line that passes tangent to this ground ellipse. And again, just like we did, we can follow where this kind of tangent point meets. We can follow that vertically up. It's almost in line with this first calculation here, red vertical line, and plot a point here. And this is where our final angle line is for our cylinder. Now, just like I gave that paper example before, so this is our top face. Because it's an ellipse, we know that it's going to cast an ellipse onto the ground somewhere. What we have here, we have 3 points for our shadow. They represent sort of ellipse points. Now, because we have these lines, we know that these lines correspond to roughly the center of the ellipse. And we know that because this is tangent to the far edge, that we can draw an ellipse that is then tangent to this first angle line that we drew here that's on the far right. So I'm going to go ahead and ghost this ellipse in. And again, just like we know that vertical edges correspond to direction lines, even though this cylinder doesn't have an edge, we're taking the widest part of the cylinder where the light is hitting. And this is what is obscuring the light to cast a shadow on the ground. And I can take these direction lines on the ground and draw a shadow line to it in the same line as it to get my shadow. Now my ellipse is a bit rough here, but you should notice another relationship between this shadow ellipse on the ground here and this base ellipse here. If I were technically accurate, this ellipse and this ellipse, you should notice, are roughly the same. And that's because they are equal distance from the horizon line, because we're taking a light that's directly to the left of it and plotting our shadow with parallel lines. So that is a good relationship to be aware of when it comes to shadows on cylinders, is when you're plotting the ellipse on the ground, it's going to have the same relationship we talked about, where anything closer to the horizon is tighter, and anything as it gets further from the horizon, the minor axis gets bigger and closer to a circle. So like a really quick way to plot a shadow on a cylinder using what we know is we can say, all right, if this ellipse minor axis is this big and the top minor axis is this big, if my shadow's here, as long as my minor axis is smaller than this one but larger than this one, that could be the start of my shadow for my cylinder. And now we know that the light passes parallel to the widest edge of these ellipses, or like tangent. So we can connect a tangent line from this bottom ellipse to this one, and same on the back edge, tangent that way. And that's a really quick way to plot a shadow on a cylinder that again is kind of a shorthand if the full calculation is a little more confusing. Again, we're just using tools that we already know. We know that these lines are tangent to the widest point of the cylinder. So again, it's going to correspond almost like directly beneath where this one passes. And we know that this ellipse is roughly the same size as these two, top face and bottom face, but making an educated decision on how big the minor axis is, making it smaller than this one and larger than this top one. Moving on. So the next cylinder is a little bit confusing. If you recall, I gave you guys the tools to plot what a paper thin wall would look like as a shadow. And that's going to be useful for plotting this steamroller wheel. So let's start there. We're going to break this again down to the basics. Again, thinking about the original example of the actor standing in relationship to the light and what this angle casts. And again, it's just a triangle here to get this part of the shadow. So to begin with, we're only going to look at this front face. And again, this is why it helps to construct, if you're drawing your cylinders yourself, it's going to be helpful to draw a prism, or a cuboid, to plot where your cylinder exists within. This will be very helpful for this. So right now what I'm looking at is this ghosted underlay face on this rectangular prism that this ellipse exists within. And this we're gonna plot this onto the ground first as if this is just a sheet of paper. So again, if this is our top corner, we're gonna have, let's just have our angle come down here like this. We know now that if this is the angle line, the direction line is going to correspond on the ground plane vertically beneath it. And again, we're just taking a left to right lighting source. So this is our first points. Now, because we're plotting just this face and we need to figure out where this ellipse goes to, it will be helpful to plot this edge. So again, we're going to take another angle line here. And again, the angle line represents the height of the objects. And we're going to take another direction line that corresponds vertically beneath it. And plot this here. And now really roughly what we have is, if this is a sheet of paper and we're getting this sheet of paper on the ground, we have this line, and then this top line represents where these are connected. And these vertical lines, again, correspond to these direction lines on the ground. Now, because we know that our ellipse exists on the sheet of paper, and now we have this like kind of oblique, like a skewed sheet of paper on the ground here, we can also plot this ellipse down here. It doesn't hurt to do one more plot, which is the center here. So I have the X, and we can do the same thing with the center here. We can take our angle line, again, trying to keep everything parallel. And our direction line is directly beneath it. And we know that now this is our center here. We could also find our center, I'll do it in blue, by drawing an X on this kind of now diamond shape on the ground. But what we're going to do is, because again we know this ellipse exists on this face and we just plotted this sheet of paper on the ground, if we pick the rough centers here, we can draw an ellipse now on this oblique face. And that's going to represent the start of our shadow. And now hopefully that makes sense. We can do the same on the back, but again, I can show you a shorthand. So as we cast our shadow now, this line is passing through this center intersection. It's really close to the tangency of this edge here. And really that's what's important. So we're going to have a line that passes tangent to this elliptical face. And it's a little confusing because they're really close, but you'll notice that it's starting to intersect this ellipse we plotted on the ground roughly here. You could do the same thing to find out what this angle line corresponds to. You know what? I'm going to take a different color for this so that it's not as confusing. Let me back up a bit. So I'm going to take this orange here. I'm going to draw an angle line that is tangent to this front ellipse face of this cylinder. And now where this meets, I can bring this line down to my ground plane. And again, that's why it helps to have this prism behind here. Here's my ground plane. It's not, it might be confusing. It's not where it intersects the ellipse, it's where it intersects the ground plane. And now we're going to have a horizontal line that comes across. And now here is our intersection point of our triangle. It's really close to this ellipse, and I'll tell you now that accurately it really should, if everything aligned perfectly, this point should also intersect with this part of the ellipse for the shadow to look correct. We're going to do the same thing over here. And again, if this is the long, complex, plot the sheet of paper on the ground, I'm going to show you the shorthand now on this side. So we have our angle line. I'm going to draw another one that's parallel, just touching this back face, again, tangent. And then where that touches, we're going to bring a line down. And because there's less lines on the back here, hopefully it's clearer. It's going to correspond to where it intersects on this ground plane of the prism. And now we're going to have a direction line that comes across from left to right. And again, this is where this intersects. And we know now, again, it's confusing because there's no edge that we're plotting, but it's kind of like this, you know, really you can think about a cylinder having infinite edges all the way around as it wraps. So we're making up this edge here, and this is where the light's hitting, and again, it's tangent. So this is where it's going to cast the furthest point. And so now we can represent this edge here. And again, the more accurate way to do this is to have it come tangent off of this ellipse here. Now on the back here, we could take the time to plot the same paper onto the ground. But we know that it's this kind of really tight and obscured ellipse. When it comes to shorthanding shadow plotting, as long as you know the basics, you can take some of these shortcuts. We can take a really tight and obscure ellipse on the back here that kind of meets in the center. Ideally, it's traveling in like a similar direction as this, minor axis wise. So this one's kind of going this way. And we can kind of, you know, essentially fudge what this back edge looks like. And so then when it comes to plotting the shadow of this cylinder, it's going to look something roughly like this. It's kind of like these really soft curves on the edges into the straight back here. And again, plotting the shadow, or finalizing the shadow rather, with some horizontal marked hash marks, or parallel marked hash marks. Hopefully that makes sense. Again, please email me with any questions, and when I'm back in class, I'm happy to cover these again and answer any questions for clarification. Okay, last but not least, the sphere. And then a quick cover on orthographics. Plotting the shadow of a sphere is similar to some of the things we learned with the cylinder. Just like the others, it's very helpful if we have an underlay here that plots roughly where the sphere is located in space. And again, here I'm using the shorthand where there is a cube that has a circle within it that's roughly touching each of the outer edges. And basically, again, this cube, what it does is it tells me where our ground plane is. And actually what's important on our ground plane here, if I use my Prisma pencil, is to find out where the center of this cube is. And this gives us roughly where the center of the sphere is located. And that's helpful for plotting this shadow. So again, if we take our lighting, what's similar to the cylinder is we're going to take an angle that touches the edge of this sphere, tangent, and bring this all the way down. Now, just like with the cylinder too, opposite where this angle line touches, there'll be another one on this left side. And this is because the shadow is as wide as the object. So we're taking this parallel line, and opposite tangent, we're going to plot another parallel line, which represents the angle. Now, because we know that a sphere is a circle in space, when it casts a two-dimensional shadow onto a flat surface, a horizontal ground plane, it's going to represent a circle on that ground plane. And we know that a circle in perspective and skewed is represented by an ellipse. So essentially these two angle lines, corresponding with finding the center in the bottom here, is going to correspond to an ellipse on the ground. Now, this is a little bit confusing because it's a bit different. There is no direction line that we're necessarily plotting here per se, directly beneath the angles, but what I'm doing is I'm finding the center, and this is now my direction line. And what I'm going to do is I'm going to plot an ellipse that's tangent to these two angle lines, that's centered on this sphere. And because I know that the sphere exists within a box that has this face that's roughly this big, I can say that the minor axis of this ellipse is roughly going to be equal to the front and back corners, because again, that's roughly the overall width of our sphere here. And again, this is just a shorthand to get us close to where the shadow would be. This is a bit messy, but really this ellipse would pass just a little bit outside here. Of the cast shadow of our sphere. And working with parallel plotted lines on the ground plane. Another way to think about this is it's as if we're plotting a cylinder onto the ground that's passing, you know, if this is the face of a cylinder here, this might represent, the shadow might represent the base of the cylinder that's passing, you know, through this sphere. It's kind of like a cylinder at an angle. That's another way to think about it. For some people that helps. If that made it more confusing, then don't worry about it. But again, it's just another way to think about the shadow. Just like all things with the sphere, it's kind of complicated when you get into the technical aspects of it, but the basics of it are pretty simple. If I draw a couple spheres here, it all depends on where it is in location to your horizon line. So if this sphere is really close to the horizon line, your shadow might be an ellipse that's really tight. If it's really far from the horizon line and we're looking more down on top of the sphere, it might be an ellipse that looks roughly like this. So when it comes to plotting a shadow on a sphere, it's basically an ellipse on the ground that is really mainly determined by the direction or the relationship of the sphere to the horizon line. You'll notice here, for example, like this ellipse got a bit bigger. Again, it's all about getting us close. It really doesn't matter too much if you go a bit bigger with your ellipse in relation to that sphere. So again, a sphere can be simple or complicated depending on, you know, how you might look at it. All right, that covers the shadows on the basic shapes. I just want to go through and roughly talk about orthographics for each of these. So let's start with the sphere here. This one's really easy. Sometimes the front face is unclear, and it can be up to you to determine what it is. But if I label the faces in the cube here, and maybe let's say this is A, this is B, and this is C. A might be our front face, B might be the side, and C might be the top. But we know that no matter where a sphere is, it's represented by a circle. So the way I like to start my orthographic views is by plotting essentially 3 rough squares here where they're going to exist. And what that does is it helps try to keep everything in line. So these aren't perfect squares, so the circle might be a bit funny in them. But on this A face, the sphere looks like a circle. On the C face, the sphere looks like a circle. And on the B face, the sphere looks like a circle. So an orthographic view on a circle or on a sphere is very boring because essentially it's the same thing 3 times. But what's important here that I've roughly represented is that all the circles are the same size and that they align edge to edge. To take it a step further, in terms of like clean composition, these spacings should be roughly equal. Let's look at what an orthographic view on some of these other shapes might look like. So again, with this cylinder, I'm going to do the same thing. I'm going to set up my edges here. Maybe I'll do a bit more considered effort to get that spacing equal on this one. And so now same thing. Let's call this A, B, and C. Now, to me here, it makes a little more sense for the B face to be the main view. And because we want this to represent a perfect circle, that B face is going to look like this. Now, actually, technically, this back face here, let's call this the D face. Technically, this view here would be the D face. Now, we're going to imagine what this cylinder looks like if we were looking at it 2-dimensionally from the orientation of A or D. And while it might be a bit confusing, we know that it touches the bottom here and it touches the top here, and it has a flat front face and a flat back face. That side view from the orientation of A or D actually looks like a square. And again, that's because this is our B face here, and this is what the B face looks like from the front. And this is the opposite face back here of this ellipse that we don't see all of. That's this face over here. Now the top face C, also the same thing. You know, we have flat faces on either side, and it goes to the full edge. It's going to be another box. So this is what the orthographic view of this cylinder lying down looks like. And again, what's important is that these edges, even though this is a bit messy, aligns with the edges of this circle here. Next up, the soup can. Same thing. I encourage everyone to start your orthographics by plotting out lines here. Again, making sure your gap is about even. And I'm trying to get these to be as close to squares as I can judge by eye. Now here again, same thing. Let's go A, B, C. Now in this instance, the C face is going to be the top view. So that would be this one here. This is going to have the circle on it. And we know from the other cylinder that A and B are basically going to be rectangles or boxes. It depends on, you know, your ellipse, whether it's a vertical, or sorry, whether it's like plotted on a cube or plotted on a rectangle, essentially. So that's what that orthographic view looks like. And finally, for this cube, which I have the shadow on the same layer, but hopefully this one's clear and you'll see what it looks like. Let's imagine just that there's some graphics on this cube with the actual faces labeled, or maybe it's an alphabet block for kids. The orthographic, again, setting up the same kind of underlay grid to keep us in alignments. Would be roughly the same. So if this is with the A graphic, this would be the B graphic, and this would be the C graphic. And again, in terms of composition for this project, just think about, you know, the 3-dimensional shape, where the shadow is in this instance, like it might have made more sense to cast it back a bit and a little bit shorter so it doesn't get into our orthographic views, and then maybe a bit of a vignette to tie it together. But that's roughly what we're working towards on this project. Again, hopefully that all makes sense. Feel free to email me with any questions, and the next time we're in class together, I'm happy to go over this. What I'm looking for assignment-wise is to have these 4 pages, cube with a shadow plot and orthographics. If you need to go a little bit smaller with your orthographics to make room for your shadow, that's okay. But a cube, both cylinders standing and laying down, and finally a sphere. If you want to challenge yourself, you can try doing a cone. It's relatively simple. I'll give you a quick hint right now what that might look like on a cone that's standing up. But if you take your direction line and your angle through this top point, it's really just tangent through here. So a cone is relatively simple when it comes to a shadow, and a pyramid is similar. All right, great. Yeah, let me know if you guys have any questions. Thanks.